Hey folks, Professor Garrett here. Welcome to week 5. We are officially over halfway through, and I just want to continue to encourage you guys to work hard as we finish up the semester. I know it's summertime, and some of you that have kids, your kids are home, and so things can get a little bit more hectic, and the routine has changed up. But I want to continue to encourage you guys to work hard as we finish up the semester. So we're going to go through our overview video as we've done in the past, and I actually want to give you not answers, but guidance to a portion of the assignment so you guys can be successful through the rest of it and try to address or clarify any questions that you might have on the front end here with this video. We're going to be going through chapter 7. You guys have your PowerPoint slides here, as well as some ancillary materials, as well as the overview or the voiceover version of said PowerPoints. So that's all standard as you guys have come to see as we've gone through the course. And we also have our weekly quiz. I hope that you all did well in the midterm last week. I'll be reviewing those this week. But if you guys have any questions or need clarification, please feel free to reach out. So our assignment this week, in addition to the quiz, is going to be the Cat 5 document. And you'll go ahead and click on that and you'll see this Word document pop up. And we're going to be looking at pages 122 and 123 specifically to address the 6-step muscle formula or motor control formula. And what you're going to do is include your name here at the top, the chosen movement that you've identified for your critical assignment, and then we're going to go through the 6-step formula for each joint at both the concentric or during the concentric and eccentric phase of the movement. So if we're doing something like a pull-up, we're going to be addressing the elbow and the shoulder. Now that means that we need to do the 6-step formula for the concentric and eccentric phase at the elbow, and the 6-step motor control formula at the shoulder for the concentric and eccentric phase, which means that you should have 4 different components or 4 different 6-step formulas all written out. And you guys need to also identify which joint you're addressing and which muscle action. So, or what type of contraction. So for example, if I'm doing the pull-up, I'll go ahead and drop this in up here, pull up, okay? And so then I'll identify here that I'm going to address the elbow, or actually, yeah, we'll go the elbow, and we'll say that this is eccentric. Okay? So then what you're going to do is fill out all these. What you'll do is you'll tab down, and the easiest thing here would just be to simply copy and paste this. So we're going to copy, paste, and then we have concentric. Okay? We're going to do the same thing again for the shoulder. So we'll copy, move down, paste, and we're going to do shoulder and the eccentric phase. All right? And then you will do the same thing for the concentric. I know that this might sound a little bit rudimentary and pretty straightforward, and it is, but believe it or not, there will still be some mistakes, and so I want to try to get ahead of those and lay this out for you guys. The reason why it wasn't pre-laid out is because each of you are going to be doing different movements, so I'm showing you that here now. But you need to have the 6-step motor control formula for all major joints, both during the concentric and eccentric. So if we're doing something like a deadlift, we'll see the hip, the knee, the ankle, and the spine. So that's 4 times 1 for the concentric in each and 1 for the eccentric in each, meaning there's going to be a total of 8 of these components here. Again, make sure that you're clearly identifying the joint and the type of contraction that's occurring. So this is for your movement here, and we're also going to have you guys address in your own words the concept of muscle redundancy, which you can read about on page 136, and use the yellow highlight text feature in Word to illustrate the muscle redundancy in your chosen movement. So when you see components that are redundant, which you guys will read about, and I don't want to go too far into that because I want you guys to explore that yourselves, but when you've identified muscle redundancy within your 6-step motor control formula, go ahead and highlight those areas. You'll simply double click, and I know that this is kind of out of screen, so I'll pull it in. So you're going to double click, say this is an indicator of muscle redundancy, double click it, and then click the highlight feature. You can also double click and then go to here and highlight there. Okay, so I'm going to need to see some highlighting on your guys' pages for this assignment. Okay, so let's see what this actually, well, let's figure this out first. There we go. So let's see, what does this look like? Let's go through this here. So we also, in addition to doing the 6-step motor control formula for your movement, you also need to do it for a squat. And you'll see how this is written out here. So within the squat, we're going to be looking at the ankle during the concentric phase, ankle during the eccentric phase. So again, what does this look like? Now, the first step of the muscle control formula is going to be identifying the joint movement. Is it flexion, extension, abduction, internal rotation, adduction, external rotation, horizontal abduction, so on and so forth. We need to first identify the joint movement. And for the squat, during the concentric phase, as we're coming up, we're going to be extending the ankle, which we call plantar flexion. Okay, so that is going to be the joint movement. All right. Now, step 2 is going to be identifying the effect of external force. So, for example, what would gravity do to our body, essentially, if our bones left, or if we did not try to stand? What essentially would happen? We now have gravity pushing down on us, right, keeping us onto the earth or in contact with the earth. So if I'm standing, I'm fighting gravity by my knees being extended and my hips being extended. So the effect of external force would make me want to flex my knees, flex my hips, flex my ankles, or in this case, dorsiflexion at this particular joint. But if it was at the hip, gravity is naturally going to want to flex the hip. It's going to naturally want to flex the knee because we have a force pushing down on us. Okay, so imagine a super, super heavy barbell. Say we get under a bar with 500 pounds on it. It's going to naturally make us want to fall down, but we're fighting to stay standing. And that's essentially what gravity is on a much smaller scale. So now we have step 3, identifying the type of muscle action. Was it concentric, eccentric, or isometric? Now, what we can look at here is in step 1, if the ankle is plantar flexing, but gravity wants it to dorsiflex, we know that this is going to be a concentric phase because we're fighting against gravity. And it's also identified here. So just as an FYI. But so if you guys were looking at, if this was deleted here, if this was no longer here, how can I identify based on step 1 or step 2 if this is concentric or eccentric? If it's eccentric, and gravity will normally push us down, right? So for step 2, but our ankle is also dorsiflexing in step 1, then we know that it's going with gravity, which means that it's eccentric, okay? But since we're in plantar flexion and fighting against gravity, that means that it's going to be concentric, okay? Step 4, as we go through this, and this should be review, we know that step 4 is going to be identifying what plane of movement this is occurring, or what plane this movement is occurring in. Is it the frontal, sagittal, transverse? So most of you, we've addressed the squat in the past, so this should be pretty familiar and some review for you guys. But the ankle, being that they're toes forward and the ankle is plantar and dorsiflexing or flexing and extending, it's easy for us to identify that we're moving in the sagittal plane. Okay, so we'll say sagittal. All right, so for step 5, ask yourself, and this is according to the book, ask yourself on which side of the joint axis are muscles lengthening and on which side are they shortening during the movement. So during the concentric phase, when my ankle is plantar flexing, the anterior muscles are lengthening, so now they're lengthening here, right? This is my shin, this would be my ankle. My ankle is plantar flexing, meaning my posterior muscles are shortening and the anterior muscles are lengthening, okay? So that's essentially going to be our answer for this portion. So we'll say that the anterior are lengthening and posterior shortening. Okay? And then step 6, the final step here, is to combine the information from steps 3 and 5. So we know that this is concentric. The anterior muscles are lengthening and the posterior muscles are shortening. So we need to determine which muscles must be producing or controlling the movement. Essentially, our agonist muscles. What are the prime movers here? And we know at the calf, it's going to be typically our gastroc, our soleus. We can go into the digitorum longus or the plantaris, but I need to see at least the gastroc and the soleus for this example here. Now keep in mind that you guys are going to be doing the same thing here. It's going to be very similar, but it's going to be flip-flop since it's the same joint. So during the eccentric phase, the ankle will be dorsiflexing. Gravity wants to naturally dorsiflex the ankle, and because we're dorsiflexing, we know that this is going to be eccentric. The plane of motion stays the same. However, the muscles that are lengthening and shortening are going to change. So now we're going to have anterior muscles shortening because now our ankles are coming up, so this anterior piece is shortening while the posterior muscles are lengthening. So then we need to still, again, these are agonist muscles still in step 6, which muscles are producing the force, and it's going to stay soleus, gastroc, so on and so forth. Okay, so areas that are going to change each time, step 1 is going to change. Step 2 is going to stay the same, right? Because it's asking what gravity wants to do, and it doesn't matter whether it's during concentric or eccentric, it's going to stay the same. So step 2 will stay the same. Step 3 is going to change. Step 4 should stay the same. Step 5 is going to change, but step 6 will stay the same. And this is something you can, in general, apply to all of these formulas or all of these steps within the formula, rather. If you guys have any questions, I apologize for a little bit longer video, but I'm hopefully clarifying what we're trying to address here. This is a way to further break down movement. So if we struggled earlier on, this should be a great way to go, okay, let's chunk this out and identify how things and where muscles are moving during exercise. And those of you that have done well earlier, this should be pretty straightforward. We're just giving you a little bit more detail in regards to how we can analyze and assess movement. As always, if you guys have questions, feel free to reach out, and I would be more than happy to answer those questions for you guys. I hope you have a great week, and again, I want to encourage you to continue working hard as we finish up through the semester. Have a great week, guys.